Charles Darwin journeyed to a new idea. Here we've got one of our famous Galapagos tortoises, one of the various different species that exist on the Galapagos Islands. Charles Darwin was a student of nature. He was a naturalist, collected insects, all sorts of specimens, really, wherever he went around the world during his 5-year voyage on the HMS Beagle. He studied biology, geology, fossils at Cambridge. He was originally going to be a reverend, but that didn't work out. I don't recall the story of it, but then became one of the most important naturalists in the world. And so typically when we hear about Charles Darwin, we think about the Galapagos Islands. Now, he went to many other places, but a lot of his interesting or most interesting observations happened at these Galapagos Islands because of the amount of diversity that existed there. And in one of your labs, you'll look at Darwin's finches, the finches on these various islands, and the slight differences that exist between them. Okay. So there are 5 major things that Darwin noticed here at the Galapagos Islands. He saw that various traits exhibited by species. He saw that different species resembled each other. Could they have shared a common ancestor? So here we've got 11 different species, and then this over here is a 12th different species of finches that existed on these islands. But they're all finches. They all look pretty similar to one another. And one of the only major differences is what they eat. So we get differences in the shape and size of the bill based on what they're eating. So is it possible that they came from a common ancestor, and then due to different behaviors or slight differences between finches that lived on these islands at first, these changes built up and they became different species? He noticed similarities between the fossils of extinct species and living species in similar areas. Could they have been ancestors? So we've got glyptodonts and armadillos, look very similar to one another. One's just a heck of a lot bigger. Okay. There are more organisms born than can survive. Okay. Some organisms are going to die and some are going to survive because of the characteristics that they have. Organisms are struggling for existence. So we see that there is competition between organisms. Okay, and those that are better able to compete survive. Those that can't die. Some organisms are more likely to win the struggle and survive and reproduce. Okay, so we see that there are certain traits that help organisms survive and then allow them to produce more offspring too, which allows them to pass on their genes to more individuals within that population. Okay. And so these 5 things again: species in similar environments have similar traits. Extinct and extant, which means still living organisms in similar environments, have similar traits. More organisms are born than the environment can support. This results in competition, struggle for survival, which means those organisms that have more advantageous traits survive longer and reproduce more and pass their genes on to the next generation. Okay. And so here is one of the definitions of evolution that I want you to know. Okay. It is descent with modification from a common ancestor. So we've got some ancestor way back in the past, and it's producing offspring. Okay. And as we go down the line and we go through generation by generation, there are small changes that are happening in the genes between various branches of this from this common ancestor and its family tree. And if these changes build up enough, we get evolution. We get this process of becoming a new species, this macroevolution. Okay. And this is done through this process of natural selection. An important thing to note about natural selection: it's not perfection. We're not going to come up with the perfect organism or the perfect method to something. Natural selection and evolution find what works. Okay. It's not going to do what's perfect. because natural selection can only work with what's there. We're very rarely going to ever make something brand new. We're just going to make adjustments to something that already exists that creates slightly greater fitness. Okay, and this fitness is the ability of an organism to survive and reproduce. Those organisms that are most fit survive longer and make more babies. Okay, and so here's a video about the rock pocket mouse. I encourage you to watch this. Go to this website. You'll have to open up this PowerPoint in Canvas. Watch this video. Really cool example of natural selection that happened over the course of 1,000 years, maybe. Really quick natural selection happening. Okay, and so I'm going to talk about this here. So if you haven't watched it yet, pause this, watch that video, and then I'm going to explain what happened here. Okay, so the color influences its fitness because of the ability of predators to see the mouse. So the light-colored mice can live on the sand and not be seen by predators, so they survive and reproduce more. The black-colored mice that come about on the sand get eaten relatively quickly because they stand out. But on the lava flows, the dark-colored mice don't get seen, but the light-colored mice do. So we see these two populations of light-colored mice, dark-colored mice, based on whether they live in the sand or on these lava flows. And so we got this quick natural selection because there was this selective pressure of predators eating those that don't have good camouflage. Okay. So the reason why we see dark-colored mice on light-colored sand is random, right? It wasn't very common because those mice would die off pretty quickly. We get some mutation that creates dark-colored mice. Cool. But if they're not in an advantageous habitat, they're going to get eaten. Okay. So mutation is random, right? There's no control over what random base pairs during replication or whatever are going to mutate and create some new trait. Okay. But natural selection is not random because nature is deciding which organisms survive and reproduce better. Okay, it's not just randomly spinning a wheel and say this guy survives better, because the dark-colored mice survive better on the lava flows because they're harder to see for predators. Okay, and so natural selection guides what alleles, right, these different versions of genes, become more common in populations. Okay, 1859, Darwin had done his work decades ago. Alfred Russel Wallace came up with the same idea, completely separate from Darwin, not knowing what he did, sent him a letter and said, hey, I came up with this idea. Darwin's like, wait a minute, I'm going to get scooped. And so they published a paper together in The Origin of Species, is Darwin's book. They published a separate paper prior to that. And so now we get this idea of natural selection being much more widespread globally. Okay, so changes that we see, organisms on Earth, same time by a creator, no changes at all. Earth 6,000 years old. Earth doesn't really change except for some major catastrophes. Okay, now I will point out that this is more Western world thought. Other things were going on around the rest of the world. But this was the prevailing thought in Western Europe, United States, and so on. Okay, after this publication, more and more people, those that were more educated anyway, started to believe organisms changed over time. Organisms have gone extinct. Earth must be older than 6,000 years. And the geology of the Earth is not constant, but always changing. That idea of uniformitarianism. Okay. And so quick review, things are in competition because they're a limited resource, fitness, ability to survive and reproduce. You should be able to define evolution by natural selection. Gene is what codes for a protein. Alleles are different versions of that gene, which can code for slightly different proteins, which could give an organism slightly better fitness.